Just to see all the question or stuff that I want us to cover in advance. Okay, Tamika?
Yes, the division of algebraic expressions we haven't done yet.
Okay, so you see now, this helps me to know, okay, well, okay, fantastic. Oh, these are stuff, some of them we did already, but let me just repeat them quick, okay? So what we're gonna do, let's start with this last, okay? Let me show you, oh, this is good, I like this. Okay, cool, I already know, but we got a cut, okay? Now let's go to Tamika, you there?
Yes,
Okay. This is exponential. Most of the exponential we did the other time. You remember?
yes.
Okay, cool. Now we go. We get a pen ready. Just a minute. Just a minute, Tamika. Get my stuff ready, 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 ready. Okay, okay, okay. We are ready. Otherwise, how was your time with your friends yesterday, Saturday?
It was nice.
Huh?
It was nice.
You had a great time with the friends?
Yes, I did.
With the girls?
Yes, we went to the movies.
You went to the movies?
Yep.
Okay, cool. Now let's get started. So we're going to do exponential, right?
Okay.
Let's do exponential. Okay, so in exponential, I'll take you back a little bit, right? Let's see how they, let's go to exponential rules. Let's start with the rules first. Let's see how the x power m times x power m. Okay, so we know this is the base. One at the bottom is base, and this is power. This is base, and this is power. So if you check out these two algebra, base and base are the same. Okay?
Yes.
And when there's a only if there's a multiplication. If there's another sign here in between, the rules cannot apply. Okay? So if it's multiplication and these bases are the same, we don't have to write them two. We only write one base. See, x power whatever. M it can be any number, then x power whatever. Now these bases are the same. We only gonna write only one base, and then we add the power. Means m plus n. Example: somebody give x power 3 times x power 8. So what does that mean? You see here, base power 8, 3 times x power 8. The base are the same. So since they're the same, I don't have to write x again. I'm only going to write only one base, and then I'll add this power.
Yes.
Plus 8. And this is total. Same as say x, 3 plus 8 equal to 11. Let's check another example. Y power 4 times square root of y. So first and foremost, we see this is y power 4, but this is square root of y. So what I'm going to do, I'm going to remove this square root.
Okay.
So I'm going to say this, and say y power 8 for the power 4 for the first one. Sorry. But if I say y square root, we say if we remove the square root, it is same as say y
1
over 2. Did I teach you that?
No.
I didn't teach you that?
No.
It's okay. So if you remove square root, it's the same as say y 1 over 2.
Why do we say 1/2?
It's a rule. Let me say slowly. If you have a square root of k, if there's no number here, we assume number 2.
Okay.
The roots. Okay? You see there's no number here?
Yes.
We're going to assume there's no number is what is 2. Okay?
Yes.
All right, take a look. If you say 2, and if you say 2 over 1, what is 2 over 1? Still equal
That's an improper fraction.
Yeah, it's improper, but a 2 over 1 is still equal to 2. Do you agree with me?
Yes.
So if somebody say 3, and if 1 say 3 over 1, it's the same thing, because 3 is just a 3. And if you say 3 over 1, it's still 3.
Mm-hmm.
Do you agree with me?
Yes.
As long as 1 at the bottom. So if I say Tamika, and if I say Tamika over 1, what is Tamika over 1?
2/1.
If you say
No.
Tamika over 1, what is the answer?
I don't know.
Okay, let me say it again. Since you do not understand me what I say in this part here. Whenever you take any number, divide by 1, you get the same thing. Okay, Tamika? If
Yes.
you take 5, and if another person say 5/1, as long as 1 is at the bottom, it's still 5. Take your calculator, say 5/1.
Okay.
Oh, you don't have a calculator. You don't need a calculator. Look, Tamika, look. If you take 5 orange and give to one person, how much that person is going to get? How many orange?
5.
5. So even if I say 5 and if I say 5/1 is the same thing. Okay, so if I say 6 and another person says 6/1, is there a difference?
There's one difference.
What is 6/1?
6/1 is 6.
So what is the difference then? If there's a 6 and 6/1, is there any difference?
No.
There's no difference. So if one says 6 and another person, no, me, I think it's 6/1. And they tell the person it's the same thing
It's the
because
same thing.
6/1, meaning 6 mangoes give to one person. 6 balls give to Tamika. So Tamika is going to get 6 balls.
Yes.
You want me to say it again?
No, it's fine.
So there's no difference. It looked like a difference, but it just simply say 1 plus 1, and another person say 2. What is the difference? 1 plus 1 equal to 2, and 2 is just a 2. So we give you the same answer. Should I say again?
You can, yes.
No problem. So if I say Tamika, and another person say Tamika/1, what is the difference?
That there is no difference.
Why?
There's no difference because it's the same.
How? Give me example.
For example, if you say 4/1, that equals to 4.
Equal to 4. Okay.
Yes.
Do you want me to say it again? I can say it again if you want.
Yes,
That part.
please.
Okay, Tamika. You have a 2 pens here. Right? These are 2 pens here. I give it to you. How many are you gonna get?
2.
Okay. And if I say 2, so what is the difference between the 2? I say I have a 2 pen. So it's 2 pen. But another person say, wait, I have a 2 pen. I want to give it to one Tamika. How many Tamika is gonna have?
2.
2. So what is the difference if I say 2 pens and the person say 2 pens divide, give to one Tamika? Is there a difference?
No.
So if you take a number and you say that number, if another person say that number divided by 1, there's no difference, Tamika. It's the same answer.
Okay.
Do you want me to say it again?
Yes, please.
Okay, no problem. I think you need some refresh a little. Okay, Tamika, if you have any number, okay. Okay, let me just erase it to have some space. Did you have some enough rest today, Tamika?
Excuse me?
You have enough rest.
Yes, I did. I had a soccer match this morning.
Okay, Tamika, 8 and 8 divided by 1 is the same thing. Is there a difference between when you say 8 and 8 divided by 1?
No.
So what that you don't understand that I can explain again? Because I want to make sure I understand what you do not understand.
I do understand it.
Are you sure? If you don't, please let me know. I want to make sure you clearly understand. But you don't have to say understand if you feel like you don't. I can repeat even 1,000 times if you feel you do not understand.
I do understand.
You sure?
Yes.
Okay, now let's get back to the business here. Sorry, just a second. Okay, Tamika, look, are you there?
Yes.
Yes,
can you hear me?
Okay, you verify from your microphone or your computer, so I cannot hear clearly. Are you there?
Yes, I'm here. Can you hear me?
Yes, but it's too far. Maybe you stay too far from your computer, so still like how you always see, how you always. Can you hear me?
Now?
Now I can hear you. Yes. Okay. So if somebody give you square root of x, let's say here there's a 3. I mean, this is a cube root. Do you agree with me? There's a cube root.
Yes.
So Tamika, look, if you say 3 and another person say 3 over 1, is there a difference?
No.
So instead of me saying 3, I'm going to say this 3 over 1. So 3 over 1. Okay?
Okay.
So if I want to remove the root, I don't want to have a root, I'll simply say leave this root and then I'll only write my x and then I'll flip this number. It's 3 over 1, right? And then I'll flip it. It's going to become what? 1 over 3. You see, 3 over 1, I'm going to change it. It's going to become 1 over 3. Flip it. Are you with me?
Yes, I'm with you.
So you have changed this number from the root to the exponent or to the power form. That's how you do.
Okay.
So the trick is make sure you have a true number here, and then if you want to write an exponential from the root, because remember this has a root, all you do is write whatever you have here, and then you flip the root. I mean, you flip this power here.
Yes.
Let me show another example. So if somebody says t, 5. So my intention here, I wanted me to have a two number.
5 over 1.
So there's a 5. I'll say I don't just want to write 5. I'll write what?
5 over 1.
5 over 1. And then remember this is in the root. So I want to write this in the power. So I'll say this, let me say what? T, whatever you have here, I'll flip it. So become 1 over 5. So now when you have a number here, let's say this is M. So there's no number here. See, that's a trick. But no, it's not a trick at all. If there's no number, we call it the square root. This is a root. These things, that's a root. But which type of root is square? If there's no number, you assume is 2. So no number, only when there's no number, you assume the number is 2. So I'm going to say the number is what is? 2. But I don't want to have only one number. My intention is to have 2 numbers so I can flip it. So if it's 2, meaning 2 over 1. And then this same is saying now, tell me how it's going to become?
M 1 over 2.
M 1 over 2. Okay, let me answer another one. Okay, let's assume there's no number here. So which number is this?
Square.
Means square. Root. Square, but what? Root. Root is that. If it's there, you call it square root. Square root. So am I going to leave like that?
No.
So it's going to become?
2 over 1.
2 over 1. But then this, if I want to write it, because this is in a root format, so I want to write it a power. Then how am I going to write?
We're going to write T.
T.
1 over 2.
1 over 2. Okay, got that? Yes. Can I drink some water a little bit, just a second?
Yes, you can.
Okay, Ellie? Okay, let me drink some water. Okay. So I'm going to do more example. So I'm going to do more example. Okay?
Okay.
And then you tell me if you understand or not. Just leave your phone. Okay. Now I'm going to do more example. Okay. So, are you there, Tamika?
Yes, I am.
Okay, cool. So, just more example, one more time. I want to make sure you clearly understand. So, our intention is to change from the root to the power. Okay, but we have a different type of root. For example, if you have that, let's say this is M, how we call this? Square root. Means there's no number here. You assume which number it is?
2.
2. So there's no number here. We assume which number it is? 2. But when you say 2, what that mean?
It means mustn't just leave it as 2. We must put it 2 over 1.
2 over 1, because any number divided by 1 is that number. So they're not going to give you that 1. Is you now. You have to say, okay, I know there was no number. That means 2. But then it's going to be 2 over 1. And then I want to change it from the root to the exponential form or to the power form. I'm going to write my m as it is here. And then I'll flip this. 2 over 1 is going to become 1 over
1 over 2.
1 over 2. So we have changed from the root form to the power form. No example. Okay, you have a t. Now look, they're going to give stuff like this. Listen, this is very important. Let's say 2, let's say here 5. And they give 3 here. Okay, just a minute. 5 and then 3.
Yes.
Now you say, well, so what I want to do, look at this. Okay, what I want to do, I'm going to start to separate. This is very important. Look this. Look at this. Look at this careful, Tamika. So I want to start to separate, right? Look, you see now they give a number and a letter. So my intention here, is to separate phase. So I want to say, well, first and foremost, the thing I want to change, look at this. The thing I want to change is I have to separate. I'm going to say now, look, I'll say 5. I'm going to separate this 5 and the root. Look at this, Tamika.
Yes.
5 and the root. And then, look what I do. I'm going to separate first. Can you see me? Can you see me?
I can't see the board there at the bottom.
Okay. 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 Can you see now the board?
No.
I think the issue maybe is on your side. Me, it seems like it's very clear here. Can you see now?
Yes.
Can you see clear? You sure? Tamika, are you very, very sure you can see clear?
Yes, I can see clearly.
Okay, so look how we're going to do here. This is very, very something which is strong. Okay, so we're going to separate this. Okay, we're going to separate. So we're going to say separate this to root. I'm going to say root of 5. Can you see what I'm doing here? And the number with the same root. And then I'm going to separate the t with the same root. With the same root. Can you see, Tamika, here? What I do is like cube root of 5 and cube root of t. Do you understand that?
Yes.
Yes or no?
Yes.
And then we're going to say, well, so I'm not going to deal with the number. Leave the number. You only deal with the letter. So I'm going to say this root of 5, I don't want to deal with it. I want to deal with the letter. So there's no number here. Which number is this?
It's a 3 over 1.
3 over 1. So I'm going to say then here there's a multiplication. It's going to be t. And then this will be 1 over 3. Do you understand, Tamika?
Yes, I understand.
I'm going to give you 2 more examples. So they're going to give stuff like this. Now let's go to the question, because this was not, they're not going to give all the stuff like that. They're going to give you something just to confuse you. That's all they always intend to do. Sorry, Tamika. Can you hear me?
I can hear you, yes.
Oh, my camera just fell. Sorry.
Oh.
I'm going to call you in a second, right?
Okay.
Okay, let's see.